if I tell you that I have a function that maps the number of feet in some distance to the number of inches in that distance, you might tell me that the function would be written as y equals f of x, where x is the number of feet, and that's the input to the function, and y is the number of inches, and that's the output of the function. You might even tell me that if that is my function that takes a number of feet and gives you the number of inches, that function, f of x, is equal to 12 times x. Because for every foot that you have, every x that you have 12 inches in that foot. But what if I told you I wanted a function that does the exact opposite? I wanted to take the number of inches in some distance and return the number of feet in that distance. Could you tell me what this function is? Well, inverse functions are exactly that. If we have a function like y equals f of x, then the inverse function, which we would write as y is the inverse f to the minus 1 of x, does the exact opposite of the function. So what happens if you put a function and its inverse into a composite function? So first we evaluate this inner function, and then we're going to evaluate the outer function. So let's take a look at an example. Say we start with 4 feet. Well, our function is 12x because there are 12 inches in every foot. And if we plug 4 in to our function, we end up with f of x, where x is 4, is 48 inches. Now if we take the inverse function will have to be x times 1 over 12. So if we have 48 inches, that gives us back 4 feet. Okay, so you might be able to find f of x and f inverse of x just based on your knowledge of inches and feet. But how do you do it in general? First, you want to write out a function in terms of x and y, like y equals f of x. Then the way we're going to do it is we're going to swap the x and y variables. We're going to solve for y as a function of x, and we're going to take the result and call that the inverse function. Then we're going to check our answers. So let's do this. Let's say we have a function f of x equals 3 times x minus 1 plus 2. We're going to write this out in terms of x and y. We're going to write y equals 3x minus 1 plus 2. Then we're going to swap the x and y variables. Okay, x equals 3y minus 1 plus 2. This can be a kind of confusing step if you're not careful, but at its heart, all you're doing is putting x everywhere you see y and putting y everywhere you see x. Then you're going to solve for y as a function of x. So I'm going to subtract 2 from both sides. I'm going to divide both sides by 3. And then I'm going to add 1 to both sides. And I end up with y equals 1 plus x minus 2 over 3. I'm going to call what's on the right hand side here the inverse function of x. So my variable is still x, but now it's the inverse function. Finally, I'm going to check my answer. So I'm going to find f inverse of f of x. So to do this, I'm going to write f of x is 3x minus 1 plus 2. I'm going to plug in my f of x as input to my f inverse of x. That means I'm going to plug this in right here. That is now my input. So now I've got my input here, and I'm going to just solve. I'm going to simplify. And sure enough, the inverse function of f of x gives me back x, which is exactly what we expect. So what about a function like y equals round of x? So remember that round of x just rounds our input to the nearest integer. So that will give me 4. However, round of 4.8, give me 5. And say round of 5.1 will also give me 5. So in this case, do you ever think that you can find a function that will take 5 and give you either 5.1 or 4.8? Well, no. Round of x has no inverse. So what about a function like f of x equals x cubed plus 3x? So I can write it out in terms of x and y. I can swap the variables. I can then solve it for y, but I don't really know how to do that. That's not obvious to me. So is there another way? Let's go back and look at something like 3x minus 6. So an easier function. I end up with a graph that looks like this. It's a simple line. And now I'm going to graph the inverse, which is x plus 6 over 3. What happens if I graph the inverse? The inverse is this blue line. So the inverse looks a lot like the original function, except it's mirrored. And it's actually mirrored over the 45-degree angle, which is the x equals y line. So if I could fold this paper in half, I'd see that the function and its inverse are the same line. So I can use that on much more complex functions. Say I have some function f of x that looks like that. If I draw the 45-degree line and I mirror it, I can get a pretty good idea as to what the inverse function looks like. So to recap, the inverse function will undo the function. That means that the inverse function of the function will give you back what you started with. But not all functions have inverses. For example, round didn't have an inverse. You can find the inverse function with our 5-step process. And if you graph the function and its inverse, they're 45-degree reflections of one another. So it's an easy way to find the inverse or get an idea as to what the inverse function looks like for really complex functions.